Hello students, today we will discuss the numerical problems from module 1. Right, in the last two lectures we have discussed the theoretical part. So for better understanding we need to discuss the numerical problems. Right, so first problem. So this is a problem which is relevant to the capacitance. Okay, so it's relevant to the higher frequency response. So given values, can see here the given values are 2 voltage, the cut-in voltage 0.814 and acceptor concentration 10 to the power 18 and donor concentration 10 to the power 16. We want to find what is the Cj and zero bias capacitance. To find zero bias capacitance, you know the formula A square root of Q epsilon S divided by 2 Na into Nd divided by Na plus Nd into 1 plus V0. The values are given here. The area you consider as 10 to the power minus 4. It will be given in the problem. Okay, square root of the charge. Charge I have taken 1.6 into 10 to the power minus 19 and epsilon S value 1.04 into 10 to the power minus 12. So predetermined value divided by 2. So then I have substituted Na and Nd divided by Na plus Nd into 1 divided by V0. It gives the value of zero bias capacitance 3.18 picofarad. Now we need to calculate junction capacitance. How we will calculate zero bias capacitance divided by 1 by Vr divided by V0. So you know 3.18 picofarad divided by 1 plus 2 divided by 0.814. So here you have a material constant, that is M. Here it is missing, you will be having M here 1 by 2. So I have taken the value will be given in the problem. Typically they vary from 1 by 2 to 1 by 3. So it gives a value of 1.71 picofarad. Okay, it gives the value of 1.71 picofarad. So next problem we will discuss diffusion capacitance. The values are given here. You can see here dP, LP are given here. You need to calculate what is a tau p and that is a diffusion capacitance. And I also given 0.1 milliamps and IP equal to 1. You have to consider approximately 1. So first we calculate tau p. The formula for tau p is L square p divided by dP. The values are substituted here. I have converted meter into centimeter. So you have 100. I just multiply with 100 for conversion. Then if you calculate, you will be getting 25 nanoseconds. Similarly, diffusion capacitance calculated by tau p divided by Vt into I, that is 25 nanoseconds divided by 26 millivolt. The current which is given here is I, which is given, I have taken Ip equal to I, so it was written as 0.1 milliamps, so 96.5 picofarad. So the next problem, the DC supply voltage is 5 voltage and R is 5 kilo ohm and cut-in voltage is 0.6 voltage and your sinusoidal, that is AC signal which was superimposing in the DC circuit, right? So that is 0.1 sin omega TV. Right, so this is a given circuit. You can see here there is a DC supply and a superimposed signal and diode and resistance, and we need to calculate what is the V0. Okay, so first we can separate the problem in the two aspects. One is the AC analysis, another is the DC analysis. So first we need to calculate in the DC analysis part, you need to calculate what is the quotient current, that is IDQ. So that you can find by your supply voltage minus your cut-in voltage divided by R. So that is 5 minus 0.6 divided by 5 into 10 to the 3. That gives the current of 0.88 milliamps. Then you want to find what is the DC output voltage. How you will find DC output voltage? IDQ into R. That is your obtained quotient current and your resistance. So you will be having V0 equal to 4.4 voltage. Then you need to calculate AC analysis. Okay, for AC analysis, consider your DC input is 0. Okay, you know the formula for small signal equivalent circuit is VA equal to IDR. By applying the KVL, I have got this equation. VA equal to IDR, small ID, capital R. So I have taken ID as common. So when you take ID common, you will be having R plus small r plus capital R. Here I need to find what is the small signal diffusion resistance. What is the formula for small signal diffusion resistance? So eta V of t divided by IDQ. Right, so already it was given Vt is 0.06 voltage and quotient current it was 0.88. So the small signal diffusion resistance it was found to be 0.0295 kilo ohm. Then we need to find what is the AC diode current. So we will find ID equal to VI divided by RD plus capital R. So 0.1 sin omega t, it was given in the problem. So RD we have found and a capital R also given in the problem. So it gives finally 19.9 sin omega t in microamps. So to calculate the output voltage, you know that is V naught equal to ID into capital R. So the output voltage is 0.0995 sin omega t. So I hope you understood this problem. Okay. So we go for next problem. The given values, you can see the given values. The R equal to 10 kilo ohm, supply voltage 10, and the sinusoidal signal which is superimposing on the circuit is 60 hertz 1 voltage peak to peak. You want to calculate what is the DC voltage of the diode. You want to calculate what is the amplitude of the sine wave signal. So default the given cut-in voltage for diode is given as 0.7 voltage. The current across the diode it was given 1 milliamps, and the material parameter it is n equal to 2 or eta equal to 2. Anything you can say, it's up to your understanding. So this is a given problem. This is a given circuit for you. So from this given circuit I was redrawn for this AC analysis by considering a diode as a RD, that is a small signal resistor. You have considered redrawn your diode as a RD. So we have studied in the theoretical part. Same I have done here. Okay. So we need to find what is your DC voltage of a diode and amplitude of sine wave signal. So very simple. So you have to be very clear in the formulas only. Right. For DC analysis, same you are using I, that is a quotient current you can find by using the formula of your supply voltage minus cut-in voltage divided by R. So 10 minus 0.7 divided by 10, it gives 0.93 milliamps. For AC analysis, small signal diffusion resistance can be calculated with the help of RD equal to NVT divided by IDQ. So 1 into 0.025, 0.93. So here I have taken thermal voltage as 25 millivolt. But default you can work like a 26 millivolt to avoid confusion. Okay, so you can take either 25 or 26, but try to be a constant value. Okay, you stick on to the any value, so to avoid the confusion. Okay, RD you'll be getting like a 53.8 ohms. So when you calculate what is the peak amplitude of a VD, can find by using this formula. PD equal to input voltage into small resistance divided by DC resistance plus small resistance. So 1 into 53.8 divided by 53.8 plus 10 into 10 to the 3. So that gives 5.35 millivolt. Okay, so this is the final answer which you obtain from this problem. So we go find DC current, small signal resistance, and find what is the AC voltage also. So next problem you can see here. See 3 diodes which are connected in series, right? 3 diodes which are connected in the series. It provides a constant voltage of 2.1 voltage. Okay, it is giving a voltage of 2.1 voltage. So you need to calculate. When there is a change in the voltage of 10% plus or minus, change in the power supply voltage. And the second question they ask here is the connection of 1 kilo ohm load resistance. So assume that n equal to 1, that is a material parameter n equal to 1. So the given supply voltage 10 plus or minus 1 voltage and R equal to 1 kilo ohm and RL equal to 1 kilo ohm. These are the given values. So from this problem, see the problem can be asked in any fashion. Okay, so you can ask like finding a resistance R for the given problem, and we can connect n number of diodes, and we can ask like finding constant voltage. Okay, but this is a basic. From this basic the problem can rise in any manner. Okay, so we can ask the question in any type, but this is a basic you need to understand. So first we will find what is the current. I is nothing but a supply voltage minus what is the constant voltage. You can see Each voltage it was set like a 0.7, so that means 0.7, 0.7, 0.7 all are the series, so you have to add. So 10 minus cut in voltage divided by your resistance 1, so you will be having 7.9 milliamps. Now you need to calculate what is the incremental resistance of each diode. So that formula, you know, RD equal to eta Vt divided by I. So that is 2 into the given value. See, it was given n equal to 2, so I have taken 2, n equal to 2, that is eta or n. You can, it's up to your convenience, you can say 2 into 25 into 10 to the power minus 3 divided by 7.9 milliamps, so you will be getting 6.3 ohms. When 3 diodes are in series, what will be the overall resistance, small signal resistance? R equal to 3 RD, so that is 3 into RD, you will be getting 18.9 ohms. Now I want to calculate what is the output variation of output voltage, that is 2. Why? Because it is given like a variation of plus or minus 1. Okay, so peak to peak it was 2 voltage into your AC voltage into R 0. It was written in kilo ohms, so 0.0189 divided by 0.0189 plus 1, so it gives a value of 37.1 millivolt. So output voltage is changed by 18.5 millivolt for each part. The positive part will be changing like a 18.5, negative part will be changing like 18.5 millivolt. That means each diode will have a changes of 6.25 millivolt. Just divided by 3, we will be getting a value of 6.25 millivolt per diode. The second part, they ask what is the connection to the 1 kilo ohm resistance. How you will calculate? I equal to what is the constant voltage across your diodes, 2.1 divided by your load resistor. It gives a value of 2.1 milliamps. So now you want to find what is the change in voltage. How you will find? So V0 equal to 2.1 into 3 RD. That is the 3 resistance. When it is in the series, we will be writing R equal to 3 RD. So it gives 2.1 to 3 RD. So you will be having a 39.7 millivolt. That means each diode have a current of have a voltage of 13.2 millivolt per diode. Okay, so this is the inference you got from this problem. Okay, the similar problems can be asked in the any manner, but this is a basic. Okay, I hope you understand this problem.